Okay guys, this lesson 2.6 deals with compound inequalities. And yes, it's going to be a little bit strange, so don't freak out over the video. We will do these together in class to make sure we completely understand them. So I kind of tried to compare this to in English. In English, when you have a compound sentence, you've got two sentences that are combined by using conjunctions like and, but, or. Well, in Algebra 2, our compound inequalities are going to be two inequalities combined by either using and or. And the first one we're going to talk about is and. Okay? So just like in English, when two or more statements are joined by the word and, make a compound statement, oh look, I had a typo. It's supposed to be the new statement is called a conjunction. All right, so I gave an example. The moon is red and the night is cold. This is joined together by and. Here's what one might look like in algebra. X plus 2 equals 5 and x minus y equals 2. Here is an inequality. Negative 2 is less than x and x is less than 1. So we're going to focus on this last one because we're talking about inequalities. So I'm going to show you this last one on the number line. So what I did, just like we've learned already, I wrote this that x is such that negative 2 is less than x. This is this first part. And I graphed it. Negative 2 is not equal to x, so I did the open circle, and anything greater than that is x. Now the left-hand side, I wrote x such that x is less than 1. Well, it's not equal to 1, so I did the open circle, and I graphed everything that's less than that, because it's less than 1. Now when I combine the two of them, I want to see, since it's and, that's a combining conjunction, I want to see what do both of these have in common. I have to have it x such that negative 2 is less than x and x has to be less than 1. And the numbers that fall within that are right in here. Less than 1, but greater than negative 2. And hopefully you can see that with the graph. Instead of using the word and here, since both of them work, this is what is going to work for both of them, and instead of saying negative 2 is less than x and x is less than 1, we can abbreviate that and say negative 2 is less than x is less than 1. As long as x fits in here, we don't need to have that and anymore, but that's what it means. Now, when we've got the elements of two or more sets that are in common, like these right here. These are what's in common between both of these. They're called an intersection, and this is what it looks like. This is where this set and that set intersect, and these are the numbers that make this statement true. Now, if for some reason you get one and you're asked to solve it and graph it, and they don't have anything in common, the intersection is called an empty set. It means there's nothing there that will make that work. All right, so I worked one out here without showing you on the number line as an example. We'll do some of both in class. All right, so down here I wrote negative 3 is less than 2x plus 5. That's less than 7. This is a big inequality right here. So what I did, this is my middle section. I can separate that into saying negative 3 is less than 2x plus 5. That's my first part. My second part over here that's included is that 2x plus 5 is less than 7. So I separated these into the two parts for you to show you that. They both have to be true, and. Now, I don't know what x is, So I'm going to solve for whatever x is, so in case I graphed it, I could do that. So I solve for x the way we've been practicing. I need to get my x by itself. So the first thing I did, I subtracted a 5 from both sides. I tried to show you in red. So -8 is less than 2x. Then I divided by 2 to get my x by itself. And that brings me with showing that -4 is less than x. All right, so this was this side of the equation. Now I want to do this, or I shouldn't say equation, the inequality. Now over here I want to do the right-hand side. 2x plus 5 is less than 7. All right, I want to get my variable by itself, so I'm going to get rid of my 5 on the left and do the same thing on the right. So take away 5. That gives me 2x is less than 2. And I need my x by itself, so I'm going to divide both sides by 2. That leaves me with x is less than 1, because 2 over 2 is 1. So when I put these together, because they need to be put together, this and right here, I can say that -4 right here is less than x. And I brought this is the same x right here, as long as x is less than 1. And whatever falls in between here is the solution. Now, because of this word and, I can kind of simplify this instead of separating it into two equations. Not equations, I keep saying that, I'm so sorry. Inequalities. Let me show you a little simplified version of doing what we did up here. I tried to do it in yellow. A much more simplified procedure is right here if we do the same thing to each inequality in every step. So I wrote the inequality. It's the same thing as up here. I just kind of spread it out a little bit to help you see what I was going to do. -3 is less than 2x plus 5 is less than 7. That's the original one we had right here. I want my x by itself. So the first thing I want to do is get rid of my 5, take away 5. If I do it here, I have to do it over here on this side of the inequality and over here on this side of the inequality, just like I did over here when I separated it. So that gives me -8. That's less than 2x. That's less than 2. Now I need my x by itself, so I'm going to divide by 2. Every side. Whatever you do in the middle, you've got to do to both sides to keep it the same. So I'm left with -4 is less than x, which is less than 1. I'm trying to show you this right here, that all of this equals the same thing. All right, now we're going to talk about the word or. Just like in English, when two or more statements are joined by the word or to make a compound statement, the new statement is called a disjunction. It's like either this or this, such as it is raining or the wind is blowing. Here's an algebraic statement. Y is an even number or y is a prime number. Now, as far as inequalities goes, which is what we're going to focus on, x is less than -3 or x is greater than 3. As long as an answer satisfies one of these because it's or, up here it has to satisfy both of them because it's and. But down here, as long as it satisfies one of these, it's a solution. So I brought this out because this is the one we're going to talk about. I went ahead and separated it and graphed it, x such that x is less than -3. -3 is not included, but everything less than that is. X such that x is greater than 3. Good. I'm sorry, I should have said -3 up here. That was right. Here, x such that x is greater than 3. So I didn't include 3, but everything above that is included. Now, the set obtained by joining two or more sets is called their union. I'm kind of unioning these together. This is the one right up here in union with this down here. Now, I brought a new example to show you how we work this out. So our inequality is negative 2x minus 5 is greater than negative 2, or x minus 3 is greater than 2. So I'm going to do the one on the left. I need to get my x's by itself, so I added 5 to each side. Then I divided by negative 2, and when I divide by a negative, my sign has to change. Here's the tricky part. Remember that. So x is less than or equal to negative 3/2. So I included negative 3/2. I filled in my circle in everything less than that. Now on the right-hand side, x minus 3 is greater than 2. I need my x by itself, so I added a 3 to both sides, and I got x is greater than 5. 5 is not included, but it's anything greater than that is included. So my solution set is x such that x is less than or equal to negative 3/2, or x is greater than 5. Now I know this is a lot, and we will do several of these together in class before I ask you to try to do some on your own. Thank you very much.